Ma'am, I shall switch off the video because of the internet lag that is there. Okay.
Yeah,
These
but you
are,
can see my screen, yeah?
yes, yes, we can see the screen. These are our
Fantastic.
who have joined
Ma'am,
us.
we
Hi,
we are on live, ma'am.
bachas. Okay. Yeah, hi. Good evening to all of you. You are sitting in the best place of the world, top of the world. So just enjoy the feeling, and I'll run through some of the slides and tell you what the place and why this place is so important. So you'll enjoy it, I'm very sure. And in the coming few days, when you'll go to the field to Sokar, to Somarari, Chumathang, and back, so you'll see it from this perspective, which I tell you. Okay. So okay then. So shall I start or? Okay. I'll also switch off my video, maybe, because we want sound. Yeah. Okay, everybody. So the topic for talking to you who are sitting in Leh today, I chose a topic: Red Planet in the Himalaya, leveraging Ladakh's unique environment for Martian research. So you know that Ladakh is a place of oops, just a second. Yeah, Ladakh is a place of great landscapes. Okay, so you'll see some of the beautiful landscapes you've ever seen. Those who are coming for the first time, so you'll really have an awesome time here. So what you see these long, broad valleys. You see the river system. You see the mountains that are barren. So what is happening here? So I'll give us, Pavitra told me to give a small introduction about myself and what I am doing, and then how Ladakh we want to use this entire landscape for our analog studies. What problems can we solve? Okay, so I've been in this area since 24 years now. 2000 was my first visit there. So I've been working in the entire Ladakh area, Kargil to Upshi, to Neoma also, Siachen till Padum, the Janskar area. So what I see the climatic changes, I see the surface processes, I see the neotectonic changes. Neotectonic changes, I'll come to it. Then since 2016, I've been seeing it through the eye of analog for Mars. How could it be? And then I'm also concerned about the geoheritage that is in this divine place. So the medium that I study is the terrestrial sedimentary deposits. Now, you all have flown from Delhi or Mumbai to Leh, yeah? So the entire Himalayan Transact you have flown over. So I don't know whether you can see my pointer or not, but if you can see the brown surface here, so that is the altitude. And you see that Delhi would be like 200 meters above sea level, and suddenly you are here in Indus. Just a second. Let me see if I can have oh, where are you? More pointer. Where do you find the pointer? Is it remote? No. I don't know. Here, let's go on. So basically, I want to say that as the altitude rises, the precipitation, which is seen in blue in the lower figure, is everything is stopped by the Himalayan front, the outer Himalaya, the higher Himalaya. Here, where you are, is highly. There is normally no precipitation. Precipitation, when I say it's the Indian summer monsoon, that is when the entire Indian subcontinent there is rain, July, August, September. But here it is a rain shadow zone. And as far as geology, you are sitting in the best place. You can see an igneous rock here, you can see a volcanic rock here, you can see a metamorphic rock here. So the geology of Ladakh just now, wherever you are in Leh, you're sitting on the granodiorite. This is the Ladakh batholith, which was emplaced, hundreds of meters below the surface, and today you see it at the surface. Similarly, when you are in the southern part, you see the remnants of the Tethys Sea. Tethys Sea sediments. You'll be going there tomorrow or day after when you'll cross Ubshi. You'll see the drastic change in the rock type. Okay, so and then the junction between these two is known as the Indus Suture Zone, because this is a suture where the Asian plate collided with the Indian plate. So this is the place. It's very nice. Its surface expression you will be stopping at that point and seeing where these two plates are meeting. Otherwise, in the entire valley, it is below the alluvial and the modern day sediments. Okay, then if you go towards the Karakoram and Pangong, so you're not going that side, there are metamorphic rocks in the area. So right from amphibolites, from the melange, the ultra basic rocks, the volcanic rocks at Khardungla and Dras volcanics, you have, and
So,
sedimentary rocks. Yes. Hello. Yeah. Can you hear me?
ma'am,
Yeah. Hello. Have you lost?
yes, ma'am, we have lost you for a minute.
Yeah.
We are internet.
Your voice is cracking.
Ma'am, can you hear us?
No. Your voice is cracking.
Hello?
Can you write?
Hello? Hear us?
Yeah.
So we were having
Can't hear you. Hello.
Ma'am, you're audible.
hello.
Okay. To them also?
Ma'am, I think there
Yes,
is some
ma'am.
problem. There is some audio problem from
My
the-
side.
No, no, ma'am. Your side is perfect, ma'am. I can
Okay.
hear you properly, ma'am.
Okay, can you help me with the pointer? Where to find it? I wanted a pointer because is it called remote control? No. Mouse. Okay, I got a mouse. No, I can't even do it. So should I go on?
Yes, ma'am. She's asking for go for the first slide, ma'am.
Okay.
She written in the chat, ma'am.
Ma'am, please go to
Okay.
the previous slide.
Okay, एक minute, huh?
Previous slide, yes.
I did something. This one?
No. Yeah, no. One more. One more.
I think that was the first. This was the first.
Yes, yes, yes. Yes, sir.
So shall I start?
Ma'am, you
So
can.
you understood, na?
Yes.
You understood that I was telling that the mountain range of the Himalaya, it stops the precipitation. And then when you are reaching, where you are sitting, Ladakh, so there is no precipitation, the Indian summer monsoon. So basically, that is why it's a desert. It's a semi-arid desert. But because of the changing scenario, I'll let you know what is happening. You're seeing a greener Ladakh nowadays, which shouldn't be. And geology wise also, you see all kinds of rocks. You see igneous, metamorphic, sedimentary. You should see the ultrabasic rocks. You see ophiolites, and there are some geologists, as Pavitra told me. So you can relate well that within a sector of 200 kilometers, you're seeing any kind of rock. There are shales, there are limestones. You could see sandstones, conglomerates. Name the rock, and it's in Ladakh. So basically, if I generalize it, Ladakh is a cold-arid desert. The altitudes are above 3,000 meters above sea level. There is very little vegetation. I won't say no vegetation, but it's above the tree line. all the trees that you're seeing there in front of in the valley, they are not indigenous. They have been bought from the Kashmir region or the Himachal region, planted there over centuries. Yeah, and this region, it witnesses extremes of temperature, because there is intense frost action, because you're seeing it in summers. Come in winters, it's all white. It's, it's intense frost action is there. Because of it, you see a lot of debris on the slopes of the hills, because physical weathering is pronounced, and there are signatures of neotectonic activity, because tectonic is evident in this place, because it is a part of the mountain building process. So the tectonics has to be there. So this is, DEM. Here, Indus, the river Indus is the backbone of the entire region. So you are sitting somewhere where Leh is written, and you would be going upstream. So the river Indus, which has its tributaries, the one of the tributaries is Nubra, that is coming from the Siachen River. Then another river which is coming from the Siachen, one of the remote tongues of the Siachen, is the Shyok, and then it takes a U-turn. Nubra joins it, and it meets Indus in Skardu, which is in Pakistan. So basically, and these rivers, they are flowing through the suture zones or thrust zones, like the Indus suture zone, like the Shyok suture zone, and there is the Karakoram fault. So all tectonic features are here, so that are also very evident. We see the rivers, they are flowing a particular direction of these sutures. Okay, so this will be the part that you will be seeing in this visit of yours. Now coming to the climate, because climate is very, very important in shaping the geomorphology of a place. So what is happening is Ladakh, most of the precipitation is coming from Central Asia in form of westerlies. So here you won't have the rains which we have in the rest of India, July, August, September, but there would be snow in the winters, November, December, Jan, Feb, you'll have snow that comes from the westerly. Yeah, so the different source is there. And rest of India has Indian summer monsoon that we are having. But you have to keep it in mind that when the Indian summer monsoon is intense, some years it's very intense, some years it's very dry. So when it is intense, those trade winds, they pierce into the mountain range, and they bring rain to this region also. So these are the years which we say extreme years, abrupt climate, abrupt monsoon. So also experiences some cloud bursts and all. So these are because of when there is an intense summer monsoon, and it penetrates into the higher reaches also. But basically, the annual precipitation is about 250 to 450, which makes it a semi-arid desert. Okay. Now, if I see the rainfall and the temperature trends of the last century, 1900 to 2000, okay, if I see the average temperature, the red one, you see there is a blue line which is going towards like this. So the average temperature of the region has increased over the last century. The average the red one is the March, April, May temperature. Okay, that's increased. The blue one is the average June, July, August, September, JJA as it's written. It's also slightly increased. And the January, February temperature has increased a lot, the one shown in pink. Okay, so what does this mean? Why are we scared about it? We're scared because in November, December, January, there's lots of snowfall, and because of this the increase in temperature in January and February, early melting starts. Okay, so by this time when you are there, July, August, September, the peaks are snow free. We are not even seeing snow in the highest peaks, which are at 5,000 and 6,000 meters above sea level. So what, that is why, because of this early melting and the high temperature, you have water everywhere, and but you have no ice because it's already melting. And this is also having an adverse effect on the permafrost, that the time that earth is getting to heat is more now. So the active layer of permafrost is getting down. So sometimes people used to say at 30 centimeters only when you dig there's permafrost, but now it's going to 80 centimeters, 130. And permafrost is a fresh reserve of water, that we really do not care about at the present moment, but our future generations would have to depend on that source of water. So it is very important to study it. Okay. So and the temperature also, it's showing a slight increase. So both the temperature is showing an increase, and the precipitation also. All this, the first panel is the precipitation. So you see how the precipitation is like zigzag, and it's, if you see an average trend, it is kind of increasing. Now, my work basically is with the lake sediments. Lake sediments, because I study paleoclimate. Excuse me. So, what happens is in Ladakh, as I said, physical weathering is so much pronounced. So you see a rock and a feature this year. Next year you come, it'll be washed away either by wind or by water, whatever. So erosion is there. So now where do I look for a climate record that is continuous? I go to the lake site. So I target glacial lakes. I target paleo lakes also, where we raise the core or do a pit. And there is an exercise for you also in Sokar. There you'll dig a pit and do the sampling. So because in the lakes every year the sediment comes and it deposits, its layer by layer by layer. So when I slice my samples, so every with time I get a record of the climatic variations that have occurred, from the past till today. So then we get the code through the lab, and then we slice it, and then do a set of lab experiments on then physical, biotic, and chemical proxies are studied to interpret the climate. So that is the work that me and my group at BSIP is doing. Now, there are a handful of freshwater lakes there or small lakes where we can just go and get the sample. But some are very big, which we really cannot go without a boat and a big system. And in Ladakh, it's very difficult to do that kind of a work. So what do? We also do the paleo lake deposits. Paleo is ancient. That once upon a time there that was. So we look for that. And over the years, we added several of these sections. So the photo that you see is brown, buff color facie, which is very fine grained. Okay, so this is clay and silt. And in the scenario like Ladakh, clay and silt can only be bought by when there is a lake system. So this is a record of a paleo lake that existed here. This is again Leh only, 4 kilometers downstream. It's called a region called Spituk. Okay, so I'm just taking you down. See the map below and the points. So this is Gopuk. This is Spol. All these places, there are lake sediments which we've mapped, which we have studied, which we have lithologged, and which we have dated. Okay. So now when I date the sediment with the radiocarbon dating and of course optical stimulated dating, so the dates are like 17,000, 15,000, 5,000, 10,000, 11,000. So now I have a history of last 20,000 years till present from Ladakh. Okay, so now what we do, we bring the samples. And this is just an example of one of the studies. So here what we've done, we have a suite of physical, biotic, and inorganic proxies are studied. So we have the textural analysis, then we have the mineral analysis, total carbon, nitrogen, isotopes, polynofacies, diatoms of all the samples, sliced 1 centimeter each. So, and then you get a climatic record, and then you interpret it in terms of like what must have happened in the last 14,000 years to here. I've just put in 14,000 years. So these are different studies, the Khalsi section, the Spituk section. Some are small sections, they give a smaller record. Some are big sections, which can give us a bigger record. So you see how the climate has changed. If you see the broad climatic zones thing, the yellow is the cold arid climate, and the greener is the warm wetter climate. So how, the sometimes there has been a very dry and a cold climate. Sometimes the green, warm and wetter conditions are coming, intermediate conditions are coming. So this is what I work with. Okay. Then the second part, you'll see features like this in the field, and you should be very vigilant and observant, because you are there to go do science. So you'll see such features. You should not just take a picture, or just even ignore them. You should clearly observe them. These are known as seismites. These are deformation structures, and they can be different shapes. They can be sand dikes, they can be folds, falls, convolutes, pinch and swell, and so on. These are formed, these are the record of an earthquake at that time. Okay. Now what happens in the lake, when there is sand coming, silt coming, and in a normal stable condition of a lake, and suddenly there is an earthquake, there's a trigger. So what happens, the sand will flow uh, clay, and the clay will flow into sand, and these structures are formed throughout, wherever, to a long wide extent. Okay. And then the S and the P waves will go, and again then the horizontal sediments will come. So this will be a very small area of this deformation that you will see. So these are called seismites, and you'll see them in the Paleolake sections. So we've worked a lot, our group has worked a lot in the Syok Tangze Valley, in Indus Valley and Spiti Valley, and we have demarcated and even dated them. So what we see is that at 27,000 years before present, then at 23,000 years before present, 19,000, 17,000, then 10,000 and 7,000, there was a major tectonic activity. And this, because of this major tectonic activity, several lakes were formed in the Indus Valley. They blocked the river and they formed a lake. Okay, big lakes. They existed till maybe thousands and thousands of years, and then where there was another tectonic activity, they were breached away. And the record of which we are seeing today in the valleys, which I showed you, the downstream Indus, when we in that slide. So basically, we in our institute, we study about both the endogenic forcing, which is outside the climate, and the endogenic, which is the tectonic forcing inside, and exogenic, which is the climate, both together, because they have to be studied together in the scenario like Ladakh, or even in any other scenario wherever you are working. So still, the geomorphic equilibrium in Ladakh has still being reorganized. It's not stable at all. Okay. Then my other concern was geoheritage. When you'll go, you'll see that lots of construction activities is taking place, and lots of very good sections that we have. Like here, this was near Kargil, beautiful lake section. Somebody was building a house, and so on. So this should also be in mind, that we are in that land, and we should also think how to preserve their structures. We should not cause harm to anybody. Hello. Hello.
Hello?
Yeah. Can I continue?
Yes, ma'am, we're here. Yes,
Okay. Yeah. So I was telling about the seismites that you
yes, ma'am.
yeah. Some of my studies has been on these seismites. I'll just go to the other slide. Here you can see that we have tried to date several of them. All these are in the Shyok Valley, in the Tangze Valley, in the Indus Valley, Spiti Valley. And you can say that they are at certain time, yeah, that this is age in years before present. So at 25, 27,000, 23, we see kind of a repetition. And the ones that are found at 11,000, they are throughout the records that we have found in the Indus Valley. So basically, this was the time when the tectonic activity took place, or seismicity took place, which was which led to the formation of several lakes in the valley. Because of tectonic activity, there was slope instability. The loose material, it came down to the narrow parts. Tomorrow when you go towards Ufchi, you'll see how narrow the river Indus becomes at places. So just now you're in Leh, it's a very wide river valley, 5 kilometers of valley to valley width. Okay, so but you'll see that. So at those narrow constricted places, the material, it blocks it and the lake starts forming. So now what is happening is and then later, due to again these seismic activities, when the lake is there for thousands of years, and one day suddenly there is again tectonic activity, and this is noticed as 6,000 also and 5,000. So we have records that several lakes were formed around 12,000, 17,000, and then they breached around 7,000 years before present. So here the Indus Valley is still frequently, it has reorganized itself to attain a geomorphic equilibrium, and both the tectonic activity as well as the climatic activities, they are responsible for this, landscape. Okay. Then the other concern of all of us should be the geoheritage, because we are in such a divine land and it's so unique. So you'll see the first photograph you see of a boulder. It's a small photograph. Well, if you nicely, there are certain carvings, and these are made by the Paleolithic people. So this is a brown rock. It's called, and the sheen on it is known as a desert varnish. So if you see a very old rock, brown and shiny, so you can say that it hasn't been, fiddled in by the people. So it has desert varnish in it. But many of the features and all are being destroyed by lots of construction work, and construction has to go because, it is the need of the day. And these are the sand ramps or sand dunes that are they taking, they are mining it for sand, they're mining it for clay. All the paleo lake sites are going. So these are things that we should be concerned about. Okay. As you're going to Sokar, I thought I'll just give you an example of Sokar also. So Sokar is a salt lake, you all know that, and here in winters it's very very cold. It's 1,000 meters more from the place you are in just now. So and it is so salty. The lake water is so saline that in the past, there is only one nomadic village. So there is no, like, you'll not see people around. There's only one village. Although because of tourist inflow, it is quite big, and you'll see some Maggie points and all. But this lake, the nomadic people used to barter salt from this lake to the Tibetan people, and it used to be nice and big. But you'll go, you'll enter, you'll see a situation like this. The water has gone. It has gone like 67, 60, 80% water has gone. So it's just kind of a wetland here. And if you see keenly in the because it's a huge 16-kilometer square area, yeah, it's a huge thing. I'll quote this Wunderman study. So there was this German group who had come to study here. So they did paleoclimate of the region in the last 15,000 years. So they say in the first picture you see a gray thing and the present blue waters that are in the lake. Okay, the lake is only this much today. But in 15,000 years before the glaciers, even the glaciers were till the lake. So just imagine, just 15,000 years, and we've lost everything. To the non-geology students, 15,000 years may seem a lot, but for a geology student, 15,000 years is like nothing, because we humans have come Earth only about 1.8 million years ago. So this is just very, very, very recent, because Earth is like 4 billion years old. So if you see that way, so this within no time we've destroyed this, and they also reconstructed the waters when both there is a freshwater lake at one side and there is the saline lake that it was a part of the same lake. So if you go there and you go for a field, you just walk around, you'll see this fine clay facies there, which is the part of the lake. It's like above the lake water today. Okay. And then if you see towards the side, you'll see a line kind of thing, which are called the paleo shorelines. So you can do an exercise there and see whether you can pinpoint the paleo shorelines that you are seeing in Sokar or not. So this just imagine, there had been such big lakes in Ladakh. So today the first panel is about the other lake, but if you see the second one, which is a schematic block, so you can see in the Indus Valley itself there were four big lakes, some in the last 10,000 years. Okay. So and today you don't see any lake in the main channel, because it's just a river channel today. But where have these lakes gone? And these were big lakes, 50 kilometers, 80 kilometers. We've done water fill models and we made these, big areas. So where we find the sediment and same contour level and fill levels, and use this MATLAB tool. So in that you get these models, and we were really shocked to see that these lakes were big, huge bodies. So but today it's not. So you are sitting on such a active or a dynamic system where things have really changed a lot. But you can say the past valleys that we see today as a river valley were, big, huge lakes, blue lakes like the Pangong. So today there is one, but that's also shrinking at a fast rate. So this was the scenario. And when I say this was the scenario, I'm not even like, I'm not joking a bit also, because today also things like this are happening in Ladakh. So I'll just run through few photographs, and then we'll come to the analog part of it. So, I take you to Pakistan. This is River Humza. So River Humza is coming, and then suddenly one day what happens, the entire mountain, it's just slides down. Reasons could be tectonic, anything. Yeah, we don't go to the reason. And then the river water is blocked and a lake is started forming. And the lake water, they just grow, they just they fill the upper side of the river, and it is rising at a level of 15 feet per day. Just imagine, because this is March time, melting is happening, lots of glaciers, lots of water. So it's just a scenario like this. So Hunza landslide dam in Pakistan, entire hill comes down, the lake starts, the river is blocked, the lake starts forming, the lake's water starts rising, so the villages that are near the lake, because every village in these areas are near the water body. So the lakes, the entire villages are underwater. Just see the condition. So rescue work is going on. People are coming to the higher levels. Pakistan Army comes and the rescue work is going on. The famous Karakoram highway, it's disrupted because of water. And then there is a 25-kilometer lake. This is, I'm talking about 2010, and people are getting rescued. and there is lots of loss of life and property. And then there is an additional danger because this is just landslide debris that has come, and now the water pressure is building from here. Every day the water is rising. What if, the water pressure is more than what the debris can hold, and it's just like this, it's not cemented. So now they start channeling the debris, and they make a channel so that the water, also excess water, it can just flow out. Otherwise, it could be flooding situation down reaches of the Humza River. Humza is again a tributary of Indus. Okay, so these things are happening in this kind of landscape today also. These are very dynamic, very sensitive, very fragile landscapes that we have. Okay, so today also when you take a flight from Delhi to Beijing, you can see that lake down there. Okay, so this is just formed in 2010. It can be there for thousands of years before any other thing, comes. So these lakes, the ones that we have been studied, are such lakes that were formed by the tectonic activities and which were breached out by the tectonic activities again. Okay, and for the sustenance of these lakes, of course the precipitation was needed, the winter precipitation was needed, the glaciers and the glacial melt was needed. So that is why we have a very good record, and we have a very good, very high resolution climatic data of these places. Now I come to how all these researchers of mine, took another direction. Well, I didn't leave the previous direction, but of course this was added. It was NASA Spaceward Bound India in 2016. So this was kind of a starting or commencing or kick off of the analog studies in India. And you all know Dr. Siddharth Pandey, who was from Amity. He initiated this program. He collaborated with several institutes, and I was one of them from BSIP, which we did this program in Ladakh in 2016. So this program is a very good program. So it's a research program and an educators program. So it provides real-time hand-on science training. It's the same as AMAZE or the ESEP that Amity had started. So it's a really good effort, and I'm very happy that 15 students are there to take part in this. So when we were at NASA Spaceward Bound, we did a lot of experiments. Like there was a field validation of ExoMars 2020 Habit instrument, and here people from 30, how many? 13 were there. 30 people were there. So different countries had their own science problem. So we started the hot springs for the origin of life and carbon metabolism in hot thermo springs thermophiles, then microbial life in the soaker salt flats. Then even artificial hypoliths were put of different rock types, and different material have been put. They're still there. It somewhere near Somarari. And then regolith mapping was done by Jonathan Clark, Professor Jonathan Clark, and then outreach and training programs was done. It was a very good program that we did. And because Ladakh has, as I told you, it has a geological, it has a ecological, and also it has a fidelity as analogous of Mars. You can study psychophiles, thermophiles, halophiles here. It's dry, it's cold, it has rocky ground, loose rock, you have permafrost, you have sand dunes, you have whatever you want to study for analog research, you get it in Ladakh. Okay, so we also wrote a paper. Okay, I think you've joined. Yeah, so we also wrote a paper. So yeah, this paper, I think it must be with you. It must have been circulated, in which we have written details about the different environments in Ladakh. And then the Earth and Space Exploration Program 2021. Again, we were there with 23 batches of students, and then we took them in the similar route that you will be going now. And so, what is happening, you are in a place you've already seen a part of Ladakh. So you know that it's not something which is very common in the world. It is like something very different. Okay, and it does look like a Mars or a moon topography is there, lunar Martian topography is there. But when we see a global analog research, planetary analog research, we see that India doesn't even have a single research station till now, in spite of us being geologically so rich. Not only in Ladakh, but in Rann of Kutch, in Meghalaya caves, in the Kolar mines, deep mines. They are like kilometers deep. We can have studies like this, but we do not have. But a dialogue has been initiated with the ISRO people. So let's see in the future, we need to have a research station of our own. So, I've already told you that Ladakh is the one of the best place. There can be several research stations. Even in Andaman, there's a volcano, like active volcano. So you can study the volcanic rocks for the Venus kind of environments in Andaman. So, but now because we're focusing on Ladakh, you are in Ladakh. So I have already told you, as far as geology is concerned, we are in the best place. Okay, it's a geological paradise. You see the rock formations like this. There is no vegetation, so it's all the more beautiful. Okay, so all the types of rocks, ultra basic, igneous, and sedimentary, metamorphic, you'll see them all through your way. As far as geomorphology or the landforms are concerned, you see that most of the Ladakh, because it's so high altitude, it has a typical glacial topography. Okay, there are U-shaped valleys, there are deflected stream courses. Sometimes you'll see a fan and the river is cutting the fan. Sometimes you'll see terraces, lots of them when you go towards Upshi now. So you'll see lots of them. So these are basically the landforms, the major geomorphic landforms of Ladakh. Now, if I see a satellite image of Ladakh, I see certain ridges and furrows, okay, in a certain aligned direction. And I know that these are the mountain ranges and there are valleys in between, and the lines coming out is the drainage pattern. Similarly, if I see this, okay, again, I'll say, yeah, there are certain mountain ranges and there are patterns of some kind of fluvial activity coming, and sometimes there are dunal things also. This is Ladakh, and this is the Juvante Chasma of Mars. So, how much similar it is. Now, because I know Ladakh, I know the process that has formed this mountain here. I can interpret it well in the satellite image or high rise image that I'm getting from Mars or the moon. Okay. In Ladakh, you'll see features like this: lots of debris, folds, falls, solifluction lobes also. So all these things we have already seen. They are documented from the Mars surface. You have these box folds. This is Sarkar et al. 2019 paper. So Ranjan Sarkar, he was in the field with me. So in Ladakh, because he wanted to test his images and to the processes here in Ladakh. So this was one of the paper, and see how beautiful the box folds are, which we could find in Ladakh also. And we know in Ladakh how these recumbent are formed, how these interference fold patterns formed, and we could give a process to the process to the things happening in our neighbor planet. Okay, then here is a alluvial fan. First is it's in Ladakh, and then second, the other pictures of the Peace Valley. So you can see, there is some a fan kind, apron kind of thing coming out. So you know how alluvial fan is formed. So that is why Ladakh can be such a good analog for studying, not only studying the superficial features Here you can see how the alcoves, channels, and aprons are in the crater wall, inner crater wall of Mars, right hand side. And then the similar kind of things we see in the high slopes of the high angle slopes of Ladakh. Okay, so one-to-one comparison. So I can give hundreds of such examples. Groundwater sapping. So middle and the right hand side image shows the water sapping, and then you wonder what is happening, what must be the process. And similarly we see it here also. Now what is happening on the surface, you see what the surface is, but below, because of global warming or permafrost activity, the permafrost is melting, and suddenly there is a gap and everything is going down in one chain. So it is called water sapping or groundwater sapping, or through frozen ground, it's melting of the frozen ground, these features come. Similarly, meandering channels. So you have lots of oxbow lakes, scroll bars in the surface of Mars, and you can just do one-to-one comparison when you see some in the Ladakh on your way in this field trip. Then permafrost is there. It's a frozen ground that has remained as such for thousands of years. So it's like a rock. You cannot. I took a JCB up there in one of the passes when I was doing my sampling. So the JCB also could not. So you can see the teeth of JCB. They could not even dig further. It's so hard. But it's a pity that it's the active layer is more now, and permafrost layer is going down and down because of the present warming scenarios. Then you have hot springs in Ladakh. So you'll see the first one, Puga hot spring, and there is one in Panamik also, and you'll see Chumathang also. So these are beautiful places where astrobiology people are very, very interested to study the thermophiles, to study the microbes. There was a study from my institute. Ansari is one of my colleagues. He has published this. What are the glucose uptake rates of bacteria, extremophiles in Puga and Panamik hot springs? So here he's studied this Puga spring, where he sees that the preferential exogenous carbon compounds for alkaline hot spring microbes vary from one place to another depending on the physicochemical conditions. So something in Puga will be different that from the Panamik. And then they also maintain a significant biomass by utilizing the exogenous carbon also. So this was one of the study. There was also another study about the anthropogenic pollution in this place. So we took some samples for diatom study. So one of my colleagues, Sunil Shukla, he did the diatoms, and then that paper is also published, and he saw that these are all due to anthropogenic activity. It's not like so we really have to be very careful while we are taking samples from here for the astrobiology point of view. We really have to be careful. Then this is again Sokar. The white is not snow, it's the salt. So you see that when you dig it, you'll find the black soil beneath. So one of the students there, Lazi, she has to collect samples from this here. So Lazi, it will look like something black carbonaceous. You can take a profile and do some samples. So this can help us tell what the we can see the biotic proxies also in this, apart from what you've already done in our lab, environmental and other proxies. So we can study the halophiles. There was another study that I was also author of from my institute. This is Varnish. I was telling you, you have the desert Varnish. So the first one is the Varnish that we found in Ladakh. So these are the samples that we took. And then we find similar rocks in Mars also. So rock Varnish, it's dark, it's shiny, it's very different. You'll come to know, especially when in the valley, you'll come to know this reddish sheen on top of the rock. But when you break the rock, it's not throughout, it's not like this. It would be light color inside. So rock varnish, a dark colored natural feature, it's rich in manganese and iron and clay minerals. It forms on the rock surfaces. And just what we found is just beneath that rock varnish, you have an extensive microbial community residing. Okay, we did a magnetic. So we found these nano chains like structures which revealed the organic signatures from these rock one. So similar things are found in Mars. So it could be a very good one-to-one study also. And then you'll see all these white fields where EVA testing, the extravehicular activity testing can be done, rovers can be tested. So it's a very, very good place to do all these activities. This picture was from AEP, ASPS 2021. So where Siddharth, one of his students, he tested a rover in the Sokar, somewhere near the Sokar. Okay, so meaning to say that Ladakh is a full pack, okay, of everything. That is why we need a research station, analog research station to be here. This is again a table from my papers. So where we've tried to just show that the geomorphic geological feature that is found in Ladakh here, where the examples are there, and then what are the Martian examples for everything: hot springs, Puga, Chumatang, Panamik, and here we in the Gusev crater you have hot. And similarly, so you have several comparisons like this for analog researchers of Mars and Earth, because both are terrestrial planets. Mars has to be like the Earth, okay? And they say there was water, there have been rivers, there's permafrost in Mars. Yeah, because they say that the Notian era, something about 3.5 billion years in Mars, was something like what Earth is today. I don't know about the trees and human life and whatever, but certainly life was there. That is, there is so much of, we want to really see whether there is life or not. And unless and until we study our extreme environments on the Earth and see what life could have be in the form of, how can we, we can just not go to Mars and go and collect samples. So we can just do a comparison, and that is best done by the researchers on the extreme environments in the Earth. So when you look at the fidelity, the geomorphological, the geochemical, the exobiological, and exploration, Ladakh, it counts for 100% of fidelity for all. Geomorphological also, I talked about all this, the landscapes and all. Geochemical also, you have volcanic rocks, you have basalt, you have shales, you have the entire Ladakh batholith filled with quartz rock, and so on, and permafrost. So Ladakh, a barren high-altitude cold arid desert with Martian or lunar topography, featuring some of the best sites to study astrogeology due to extreme cold conditions, no vegetation, high altitude, and desertic environment. So these 5 things are the because of these 5 things, you can see Ladakh as it is today, and it could be a best terrestrial analog. So let's see in the future. This is AI generated, so maybe we can sit on one of our research stations in Ladakh someday, very soon, and do our researches than sitting in a hotel and having a talk in the research station itself. So that is all from my side. Thank you. If you have any questions, I would be, it'll be really nice. Over to you, Pavitra. Yeah.
Yes, ma'am. Thank you so much for the talk. Okay. So it was amazing to have your talk, especially because it covers the Ladakh region. So we'd open the floor to some questions if anybody has any specific questions. While we still have decent internet, I request people to come forward if you have any questions. Yes, ma'am.
Hi, ma'am.
Hey.
I'm Prabjot, and really thank you for such a wonderful talk. I have a question. When Leh doesn't receive so much rainfall, how do Sokar and lakes, all the lakes which you have told about, how they will retain their water level? It will go down, or it will be like you have told it in 15,000 years, the lake has dried up. But if there is no rainfall, how they will survive? How they will survive?
Yeah, it depends from place to place. Soker is a very different setting. Also, it also depends a lot on geology. Also, okay, Soker being at 4,000 meters above sea level, still all the glaciers have dried and the lake has dried. Only one glacier comes from the southern side, I think. There's a small freshwater lake which is like keeping it alive, but the entire lake you can just just skate through the lake. There's no water at all. And I remember when in 2002 I went to Soker for the first time, and I was staying at Thukje village because inside the village we had tents. They said no, you cannot stay outside anyway, but stay within the boundary. And I used to just walk maybe 20 steps and there was the lake. I could wash my clothes and wash myself in the lake water. Today you see Thukje. You going there, you see Thukje, you'll not even see water till a long time. Yeah. So this is the entire, it's the globe, and the entire thing is the effect of the global warming also. So the glaciers have already melted. You'll not see a single glacier in the Soker side. So obviously the lake water will go, but still you have a reserve niche uske, permafrost is there. Okay, and then whenever the conditions are there, because everything is cyclic in the world, there have been very very warm phases and then again very wet phases also. It's been in Ladakh also. In 20,000 year cycle, we've seen that. So whenever the rejuvenation will come, of course, then when westerlies are active, there'll be lots of snow activity. The glaciers will rejuvenate. But when will it be? We cannot say. So this is kind of cyclic. So Soker has gone totally, but Somorari is still there because it's in a dome. There are these metamorphics. It's in a dome, so it'll sit for some more time. So something like this. But lake level fluctuations have been seen throughout entire Tibet. When you see the Tibetan plateau, because I introduced Ladakh as the western edge of the Tibetan plateau. It's nothing like India. It's more like Tibet. So even in the Tibetan plateau, there are several lakes which have been going down. Their levels have been going down. They're very well studied because the Chinese, they really study well. One student is there in every lake monitoring the levels every since a long time. So but we are not monitoring our lakes so well. So this is cyclic, so you don't have to worry about it. But whatever is the best from our side, we cannot say we can revive it or put water in it. It will come with its natural thing only. So that is why we really have to be careful if we are bringing tourists there, because that's over exploitation. Yeah, whatever resources, it's over exploitation. We're bringing tourists to Ladakh, where the capacity is to feed 1 lakh people. We are like 10 lakhs every year, so something like this. So these are the things that have to be balanced. So things, we can see them as they are for a longer time. Otherwise, then I've started so many paleo lakes, and then when I just imagine, oh my god, just 3,000 years back there was 100 kilometers lake here. You can't even imagine. So yeah, but Himalaya is dynamic. What to do, it'll happen like this.
Thank you, ma'am. Yes, please come. Ma'am, we have one more question.
Hello, madam.
Hi.
Thank you for the, it was quite informative, interesting. I have one question regarding the artificial hypolepsia. If you could little bit elaborate on that, artificial hypolepsia.
Oh, okay. So this there from Chicago, there was a educator. He was a high school teacher who came with us in the NASA Spaceward Bound. So because NASA Spaceward Bound is very very common in America. So they keep doing it in the Death Valley, in the Canadian part of the towards the northern part, and different places. So he had an experiment with him. So he had this a box of a piece of it was maybe 2 inch by 2 inch different materials. one was marble, one was something black, different kind of stones, and also plastic. So he had them. So what he was thinking, what his experiment was, that he will place it at one place, yeah, and then cover it, and then sunlight is coming. So he wanted to see over the years. So 2016 say abhi 8 saal ho gaye hain, so maybe after 10 years we would just go and pick them up, each of them, where he's placed it, and then see ki life kiske niche grow hogi. Okay, where things will come, which what is the medium to for life to proliferate. So that was his experiment which he was doing. So we placed these hypoliths in the route from Puga to Somarari also. So let's see, maybe after 2 years we return and see, and then experiment, put them again, then another 10 years later, you all could go and see, so that, you have this real-time experiment there. Okay. Hello. Hello, am I audible? Hello.
Yes, yes. Oh, can you see us now? Okay, okay.
Okay, yeah. I can see all of you now. So any more questions?
Does anyone have any other follow-up questions?
You can just write to me also anytime, and call me anytime if you have any queries. And now that you'll be in the field, just try to observe. Just don't sleep in the bus or the vehicle, because these they are very nauseating also, these trips. But you try to give yourself, what is in the right bank of the river, what is in the left bank of the river. Let me see what are these, what is this. Try to observe anything, any small thing also. So that will be really nice, and to keep your mind occupied also, and then take you out of the sickness that you all must be feeling at this point of time. And you'll feel it for 1 or 2 days, but once your mind is occupied with something other that's interesting, I think that's the best. Otherwise, you keep telling, oh, my head is hammering, dard ho raha hai, feeling low, nothing like this. And please wear proper clothing. I see some of you in your, dresses. So please, you have to really take care. गरम भी लग रहा है ना, तो भी पहनो jacket और ये सब. एकदम expose करने से बिल्कुल नहीं चलेगा. So there are certain do's and don'ts. So you really need to. This is Ladakh. So it's like they say, don't be a gama in the land of the lama. So as the lama there, you have to go by the rules here. So just be comfortable, don't panic, and observe a lot what is going on. There's thousands of things. Apart from taking good pictures, you can have a best photo contest also. So that could be really nice. And there would be certain exercises that have already been planned by you, by your teachers. So I wish you all the best for the upcoming fieldwork. I wish I was there, because Ladakh is kind of my second home, and really, really love to be there. But I have to be there in September end, so couldn't come at this time. So all the best, and I look forward for your queries and your connect with me whenever, even after this trip. Okay. So
Okay, thank you, ma'am.
then it's and Pavitra, yeah, bye. All the best to you. So I think it will be really good. Okay, bring lots of samples. Let's do some good research. Yeah. Bye. Bye. Besties. Bye.
Yes, Mobin, you can now close the session.
Okay, ma'am. Thank you.